All right, welcome back to the notes. We're going to example 2. We have 1 plus x dy over dx minus xy equals x plus x squared. All right, so the first thing that we're going to do is we're going to divide everything. It's not in standard form, so we're going to divide everything by the 1 plus x. So we get dy over dx is equal, why do I keep doing that? Minus x y. I'm going to write this as, because I want that y to be by itself. So 1 plus x, put the y right there, is equal to, now I'm going to go ahead and say, I'm going to pull out an x and get the 1 plus x there, and I'm dividing by 1 plus x, so that right hand side is just going to equal x. And so just to save some room, you watch the video, that's just going to equal x. All right, now we have it in standard form. What's our p of x? Our p of x is equal to negative x over 1 plus x. Now, what we're going to need to do here is we're going to write this as the exponential, so the integrating factor, so it's going to be e to the integral of negative x over 1 plus x dx. And so now we have to be able to integrate this left-hand side. All right, now again, I like to attack this before I do it to both sides, but again, I'm going to go ahead and show you. Okay, so now we're putting in the integrating factor. So since we found the integrating factor, we're going to have this. So we have d over dx times e to the integral negative x over 1 plus x dx times y is equal to the right-hand side, which is going to be e to the integral negative x over 1 plus x dx times x. All right, now I'm going to go ahead and do the integration to the exponent. So over here, I'm just going to go ahead and rewrite it as this. So I'm just looking at the integral from negative x over 1 plus x dx. And now, looking at that, I notice, okay, the order on the top is the same order as the bottom, meaning it's x to the first, x to the first. So what I'm going to do is I'm going to go ahead and introduce a 1 and then also put in a negative 1. So I'm going to have negative x minus 1 plus 1 all over 1 plus x. Again, because I'm adding that to the exponent, I'm adding 0. Negative 1 plus 1 is 0. And so I have that. Now I can rewrite that to be the integral of negative x minus 1 over 1 plus x plus 1 over 1 plus x. And then that's all going to be dx. Now, I'm going to rewrite it again. The integral of, I'm going to pull out a negative right there, and I'm going to have negative x plus 1 divided by 1 plus x plus 1 over 1 plus x dx. Hopefully you notice, oh, that's just going to be negative 1 plus 1 over 1 plus x dx. And now let's go ahead and integrate. So when I integrate negative 1, I still get negative x. Let's integrate 1 over 1 plus x is going to be natural log of 1 plus x. And so now this can be written as e to the negative, I'm going to write the natural log first, natural log of 1 plus x minus that, let me make sure that looks like a absolute value sign, minus x, which when I convert this is going to be just e to the natural log of 1 plus x times e to the negative x. I'm just breaking up that minus x to be times e to the negative, or I could say divided by e to the x. And that way I can write e to the natural log of 1 plus x, so it's just 1 plus x times e to the negative x. All right, so now I know that my integrating factor to the integral negative x 1 plus x dx is just going to be 1 plus x times e to the negative x. And so now I'm going to rewrite my integrating factor over here to be, all right, d over dx, and then 1 plus x times e to the negative x times y is equal to 1 plus x times e to the negative x times x. All right, so let's go ahead. We got to integrate both sides. So now I'm going to integrate both sides. Let me try to use the color I haven't used. So I'm going to integrate the left, and I'm going to integrate the right. All right, dx. So the left-hand side is just going to be 1 plus x e to the negative x. Then on the right-hand side, to make it, pretty easy, I'm going to go ahead, forget my y. I'm going to go ahead and multiply 1 times x, so x e to the negative x plus x squared times e to the negative x. Now, I've got to integrate this. Which, again, is no small task. I could have kept it, x, and then integrated that way as well, the x squared plus 1s. But to me, it's easier just to go ahead and write it as x e to the negative x. So I'm going to break this up to be the integral of, now I'm going to change the colors just so that you can stay with me. So the integral of x e to the negative x dx plus the integral of x squared e to the negative x dx. So I just broke up the integration. Now, for the left-hand side, what I'm going to do, I'm going to kind of do that tic-tac-toe method that you were taught in Calc 2, where we have x e to the negative x. Again, you can use the UV substitution. This is just, it's quicker to do it this way. Take the derivative of x is 1, take the derivative of 1, that's 0. Take the antiderivative of e to the negative x, which is e to the negative x. Antiderivative of that is just going to be e to the negative x. Then we take our crosses, and so then that first term is, when we integrate it, it's just going to be negative x e to the negative x minus e to the negative x. And then that's finished there. We finished that already. And now we do it again, but we're going to do it with, tic-tac-toe method, but with x squared and e to the negative x. And again, plus, minus, plus, minus. And so we get 2x, keep taking the derivative as we go down until we get to 0. Then do antiderivative with the exponential. And then we take the crosses of that. And so then we get, looks like minus x squared e to the negative x minus 2x e to the negative x minus 2 e to the negative x plus c, because we finished that. All right, and so that does it for, the integration method. I'm going to go ahead and just move all this down so that you can, so that we still have room. All right, and on the left-hand side, we're still, let me keep that in orange, we're still 1 plus x e to the negative x y. All right, and then my Apple Pencil's low. So 1 plus x e to negative x times y. And now we're just going to divide everything by 1 plus x e to the negative x. I want you to see that everything has an e to the negative x, so they're going to cancel out. I'll just rewrite this as 1 plus x e to the negative x times y is equal to, and then on the right hand side, I'm going to go ahead and just pull out all my e's to the negative x. So e to the negative x, and you can actually simplify this even more. You know, I'll bring, just because these are notes, I'm gonna just bring everything together. So it's just gonna be negative x squared e to the negative x, and then I have some like terms like that negative x e to the x, so it's gonna be negative 3x e to the negative x, and then I get those, so and then minus 3e to the negative x, because again, some more like terms. Plus c, I'm going to pull out an e to the negative x, and I'm just going to get, I'm going to pull out a negative e to the negative x. That way I can get x squared plus 3x plus 3 plus c, and then that's just equal to, why did that pop up? 1 plus x e to the negative x times y. And then now divide everything by 1 plus x e to the negative x. And, you know, when I do that, I'm going to get y. And I'm going to do this in a different color because here's our answer. Y is equal to, that's going to cancel out. I'll just say negative, and you can simplify this even more, but just because we don't have the room, x squared plus 3x plus 3 divided by 1 plus x. What we can do is we could take the first two terms, pull out an x, but we could change it to x squared plus x, and then to 2x plus 3. But we're not going to do that. You don't have to do that. And then plus c, and that's going to be 1 plus x, and because it's e to the negative x, it's just going to be e to the x on top, and so again that's a c. All right, so this is our differential equation. Here's our solution. Now what's our largest interval? Well, hopefully you noticed, okay, we can have a negative in the denominator, so it's -1, and that's the only place where there's a restriction on our independent variable. All right, and so because there's a restriction there, it'd be from negative infinity to -1 and -1 to infinity. Our largest interval would be -1 to infinity, and then we want to check our transient term, so the limit as x approaches infinity for c e to the x over 1 plus x. Hopefully you notice that the top's going to get faster. It's going to get, you know, bigger, then the denominator is going to get bigger, so it's not tending towards 0, so there is no transient term for this one.